Hello, in this video we will go over properties of trapezoids and kites. So, did you know that a trapezoid has one pair of parallel side and a kite has only one pair of opposite angles that are congruent? So we're going to compare and kind of like contrast between trapezoids and kites. Okay. So over here, it looks like we have some kind of trapezoid, and in a trapezoid, oops, going back. So yeah, in a trapezoid, let me go Yeah, and a trapezoid, here's a trapezoid. And a trapezoid is basically a quadrilateral, exactly one pair of parallel sides. So in the previous video, you learned that a quadrilateral has two parallel sides, but in a trapezoid, there's only one pair of parallel sides. This side is parallel with this side, and if you look at the angle base, angle A, excuse me, angle A and angle D are what's called base angles. And yeah, excuse me. Let's move on. And angle B and angle C are base angles. So we're going to talk about these angles. I think if you add up all the base angles, they add up to 360. Um, good. So there's different types of trapezoid. One more specifically is if a trapezoid is an isosceles, then each pair base angles are congruent. So here you have an isosceles trapezoid. And how do I know this is an isosceles? Because you have two sides that are congruent. And how do I know that? Because of this one tick mark. This means that this is congruent with this one, and that means that this angle right here is congruent with this angle. Okay. Oops. And this one, a trapezoid is isosceles if and only if the diagonals are congruent. So that's another key. That's how you determine if a trapezoid is an isosceles, their diagonals are congruent. So line segment AC is congruent to line segment BD. And that also means that angle B is congruent to angle C, right? Okay. Now let's talk about mid-segment of a trapezoid. Basically, it's the segment joining the midpoints of the leg. So here's the mid-segment. And so you can see it's the segment joining the midpoints of the two legs. Um, line segment AB is the mid segment. Yeah, yes. And line segment RB is congruent to line segment BQ, and then line segment SA is congruent to line segment AP. So the mid segment of a trapezoid is a parallel to the bases, and its measure is one half. And this is important. So the mid segment of a trapezoid is parallel to the bases, and its measures is one half of the sum of the measure of the bases. So as you can see, line segment AB is definitely parallel with line segment SR. So let me move up. So is this true? Line segment AB, RUAB, is definitely parallel to line segment SR. And then line segment AB is parallel to line segment PQ. That's definitely true. So did you know that the line segment AB, you can find the mid segment, or in our case, line segment AB, by taking one half of by adding the two bases. So base one would be line segment SR, and the other base is line segment PQ. So you add them up and then you take half of it and you get the mid segment. So basically, you can find this length, the mid segment right here, by taking this length, by adding up this length plus this length, and then dividing it by 2. So yeah, we're going to need that when we do our example. So here we have example 1. If line segment PQ is the mid segment of the trapezoid, answer the following trapezoid. Uh, Question. So we have trapezoid CDEF, CDEF, and we also know that line segment CD is parallel to line segment EF. So this line segment CD is parallel with line segment EF. What is the angle of F and what is the angle of E? So where's F and E? So we know it's not an isosceles, right? Because it didn't say so. So line angle F. So angle F and angle C are what's called, they're not congruent, but they're still supplementary. But just like in the other quadrilateral, if you add up this angle and this angle, they are supplementary, meaning they add up to 180. So we could find angle F automatically. So you could say 70 plus angle F equals 180, right? And then all you got to do is solve for an angle F. So I'm going to subtract 70, and I get angle F is going to be 110. Okay. Now, what about letter B? What would be angle E? Uh, so angle D and angle E are definitely supplementary. So you could say 100 plus angle E is 180, and then subtract 100, and angle E is 180 minus 100 is 80. So yeah, that's angle E is 80 degrees. Angle F is 110. There we go. What about C? If line segment FE is equal to 7, and line segment CD is 11, so FE is this length. They said that's 7, and line segment CD is 11. This is hypothetically because it obviously FE is definitely bigger than CD. What is the length of PQ? So the length of PQ is a mid-segment, and what do we know about mid-segment? We could say line segment PQ is equal to 1/2 of the two bases. So base 1, or line segment CD, is 11, plus base 2, which is line segment FE, which is 7. That gives you 11 plus 7 is 18, divided by 2, which is 9. Okay, so C would be 9. Okay, let's do letter D. If line segment CD is 6 and line segment PQ is 8, what is the length of FE? So PQ is still technically a mid-segment, so we could say um, PQ, line segment PQ, is equal to 1/2 of the two bases. So base 1 would be 6, plus base 2, which is, I don't know, call it X. And we know that line segment PQ is 8, so it's going to be 8 equals, so 1/2 times 6 plus X. And then you solve for X by multiplying both sides by 2. So 2 times 8 is 16, equals to 6 plus X. Subtract 6. You get 16 minus 6 is 10. So the line segment FE is going to be 10. Right, not too bad. Okay, let's move on to another example. So determine if the trapezoid is isosceles. So what do we need to know? uh, What do we need to know in order for this to be an isosceles trapezoid? That means that this length is equal to this length, right? But they don't give us any length. They give us like coordinates, right? Uh, but they give you, yeah, this is actually coordinate B. So coordinate A is this, coordinate B is, let me label this better. Coordinate A is 0, comma negative 2. Coordinate B is 0, comma 4. Coordinate C is 5, comma 4. Coordinate D is 8, comma 0. So there's actually two things. The diagonals must be congruent in order for the trapezoid to be isosceles, and they must have the same slope. They must have the same slope, so that means they must be parallel. So let me write this. So in order to prove that this is an isosceles trapezoid, the diagonals must be congruent in order for the trapezoid to be isosceles. And it must have the same slope. The same slope. So that means it must be parallel. So how should we do this? Let's find the length of AC, and then let's find the length of BD. What do we? So AC is, where's AC? From here to here. We could find the length of AC using the distance formula, right? So we're just proving that uh these diagonals are the same, and then we'll find the length of BD. Okay, so let's find the length of AC. So everything's given. We don't need any, we just need the distance formula. So length of AC, and we are given the coordinates of negative 2, comma 0, and then the coordinates 5, comma 4. Okay, so this is x1, y1. This is x2, y2. So the distance is going to be the square root of x2, which is 5, minus x1, so it's minus 2, square plus y2, which is 4, minus y1, which is 0, squared. And you get two negatives becomes positives. 4 minus 0 is 4. 7 squared is 49, plus 4 squared is 16, and then 49 plus 16 is 65. Okay, now let's find the length of BD. If they're the same, that means they are an isosceles, right? So BD. The coordinate for B is 0, 4. The coordinate for D is 8, 0. So this is x1, y1, x2, y2. So it's going to be x2, which is 8, minus x1 is 0, square plus y2 is 0, minus y1 is 4, and that gives you square root of 80. So this is not an isosceles trapezoid because line segment AC does not equal to line segment BD. So you could say no, the trapezoid is not isosceles. Let's move on to example 3. Okay, example 3 says trapezoid ABCD. If line segment AB equals x, and line segment PQ is x plus 5, find line segment DC. Uh, we can do that. We have the mid segment, and so we could set it up as line segment PQ using your mid segment formula. Line segment PQ is equal to 1/2 plus line segment AB plus line segment DC. Okay, so it's going to be 1/2. Do we know the line segment of AB? Not quite, so we'll just call it X right now. Do we know the line segment of DC? Hmm, no, we don't. So I'm just going to call it line segment DC for right now. Do we know the line segment PQ? Kind of. It was given as X plus 5. Now all we got to do is our final answer won't be an actual value, it'll be in terms of X. So all we got to do is isolate line segment DC. So first, I'm going to get rid of this 1/2 by multiplying both sides by 2. So it's 2 times X plus 5. Here, 2 times 1/2 cancels, so you're left with X plus line segment DC. And then we do next, we can like for this out, so it's going to be 2x plus 10. Solve for x, so you're going to subtract x. 2x minus x is x, plus 10 equals the line segment DC. So example 4 says trapezoid WXYZ. If angle W is 2n, angle X is 3n minus n, angle Y is 2n plus 50, and angle Z is n, find M and n and measure of each angle and determine if the trapezoid is isosceles. Okay, so they give you this 2 image. I kind of wrote it out. So they say that angle W is 2n, and then angle X, yeah, so angle W is 2n, and what else do they say? Angle x is 3n minus 10, and then angle y is 2n plus 50, and angle z is n. Find m and n. Uh, how would we do this? So how did I get 60 here and then 74 here? So if you recall, if you add up all the angles, they add up to 360. But more specifically, if you add up this angle, this is supplementary. That means they add up to 180. And then if you add up this angle plus this angle, it's also supplementary. So let's try to do that. Let's see if we can figure out if that even helps. So 2n plus n equals 180, which is 2n plus 1n is 3n. Divide this by 3, and you get n equals to 60. And then over here, if you add up these two angles, you get 3n minus 10 plus 2n plus 50 equals 180. Will that help? 3n plus 2n is 5n. Yeah, 3n plus 2n is 5n, and then 50 minus 10 is 40 equals 180. And then subtract 40, you get 5m equals to 180 minus 40 is 140. Divide this by 5. 140 divided by 5 is 28. Okay, so if n is 28, that's how I got this. N is 60, so that's how I got 60 here. And then this angle here is, if you kind of plug in n, it's 3 times 28 minus 10, and that gives you like 74. Can we find out this angle? Yes, and can we find out this angle? Yes, because they are also supplementary. So if let's look at angle W. Angle W would be 60 plus angle W equals 180. Or actually, it says it's angle W is 2n, so that's actually easier. So angle W is 2 times n, and n is 60, which is 120. And then what about this angle here, 2m plus 50? That is 2 times m, which is 28, plus 50. And that gives you, what's 2 times 28? That gives you 106. Okay, so that's how you find all those angles. A kite. So a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. So here you have a kite. It's technically a quadrilateral, and this time, a kite has two pairs of consecutive congruent sides, but opposite sides are not congruent. So not all sides are congruent. Only this side should be congruent with this side, and then this side is congruent with this side, right? So line segment AB is congruent to line segment AD, and line segment BC is congruent to line segment DC. If a quadrilateral is a kite, then it's a so if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, I think that makes sense. Here you have a kite, and it's def if here we have a quadrilateral that is a kite, that means that the diagonals are perpendicular or 490 degrees. So line segment AC is perpendicular to line segment BD. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. That means, okay, so if you have a kite We know that this side is congruent with this side and this side is congruent with this side. That means that the angle A is congruent to angle C. And angle B is not congruent to angle D because you can only have one pair of opposite angles that are congruent. So keep that in mind when we do an example. Okay, so let's do example 5. So it says, example 5 says, what are the lengths of the sides of the kite? So what are the lengths? So how will we do this? Well, do you see triangles? I see triangles. So remember, this is their diagonals form a perpendicular. So this is like a 90. This is going to be 90. This is going to be 90. So we're dealing with right triangles. Um, this length here, oh, did I there should be this halfway point is E, but E. So let's look at this triangle, triangle one. If you draw it a little better, this forms a 90-degree, right? And this is length 3, this is length 4, and then this is length 5, right? Mm, whoops. How do I know this was 5? Well, it's a special right triangle. It's a 3, 4, 5. But if you weren't really sure, 3, it's a 3, 4, 5 triangle. So, but if you weren't sure, you could use Pythagorean theorem, right? So you could do 3 squared plus 4 squared equals 8 squared. If you do the work, it'll give you 5. Um, so they just want to know the length. We know that line segment BC is 5. And then we also know that line segment DC should be also 5 because these two sides are great. So yeah, you can say line segment DC is also 5. And what else? We don't know what the length of AB, so let's draw that triangle. So here we draw a right triangle like this. And this length here is 3, this length here is 2. And I don't know what this hypotenuse like this, but we can find out by doing Pythagorean theorem. So 2 squared plus 3 squared equals C squared. So 2 squared is 4, 3 squared is 9 equals C squared. And just 4 is 7, 12, 13. So for C, C is square root of 13. So this length here is square root of 13. This length here is square root of 13. So you could say line segment AB is square root of 13. And line segment AD is, if you're curious what the entire perimeter is, I don't think they say, but if you're curious, the perimeter would be 2 times 5 plus 2 times square root of 13. So that's 10. That's 10 plus 2 square root of 13. That will be your perimeter, right? So perimeter would be 10 plus 2 square root of 13. Okay, move on to question 6. So question 6 says, find the perimeter of kite WXYZ. So we need to find the perimeter of this kite. Uh, they give you two lengths. WZ is 13 and then YZ is 13. So that's good. So you can say 2 times 13. Now I got to find the length of WX. And that would also be equal length of XY. So this length is should be congruent with this length. So let's draw a triangle. So this length is a red triangle. This is 5. Um, oh, look, oh, this right here. This should be a length. This one should be given as a 5 as well. So this is 5. Now let's find this like unknown hypotenuse by doing Pythagorean theorem. So it's going to be 5 squared plus 5 squared equals c squared. 5 squared is 25. 5 squared is 25. 25 plus 25 is 50. Take the square root. ASC equals to let's see. Wait, so what times this what's square root of 50 simplified as? Two numbers unmultiplied 50 would be like 5 and 10. 5 is prime, 10 can be broken down. So 2. So you have simple pairs of 2, so it's going to be 5 radical 2. So this length here is 5 radical 2. This length here is 5 radical 2. So the total per meter would be 2 times 13 plus 2 times 5 radical 2, right? Put it all together, we get 2 times 13 is 26, and then 2 times 5 radical 10 is 10 radical 2. Yep, we found that per meter. Now let's move on to question 7. So question 7 says find the missing angles in each kite. So here we have this kite, and we know that we have one pair of opposite angles that are congruent. So this angle B is definitely congruent to angle D. That's it. Um, I believe if you add them all up, they should all add up to 360 because this is a quadrilateral. So I think let's do that. Let's add up all the angles and let's see what happens. So we have angle A, which is 20, plus angle B, which is X, angle C is 50, angle D is also X, and they should add up to all 360. So 20 plus 50 is 70. 1x plus 1x is 2x. Subtract 70 from both sides. And yet 2x equals to 360 minus 70 is 240. Divide this by 2. You get 290 divided by 2 is 145. So I think angle B, I know angle B is going to be 145. I made a mistake. Angle A is not 20, it's actually 120. That's huge. That's a big difference. So that changes our value. So 120 plus 50 is 170. So I messed up. So it's going to be 170 plus 2x equals to 360. And then subtracted by 170. 360 minus 170 is 190. Divide this by 2. X equals 95. Okay, so that means angle B should be 95 degrees. And angle D is also 95 degrees. Okay, let's do one last example of this. Example 8. So here we have this height, and what do we gotta add? We gotta find the missing angles. So we have two angles that's given. We have angle E as 100, angle F is 70. We need to find out what angle G is and what angle H is. We actually know what angle G is because angle E is congruent to angle G, right? Angle E is congruent to angle G. So that means that angle G should equal to 100 degrees. Now, what about angle H? So this is technically quadrilateral, so you can say you can add up all the angles and set it equal to 360. So it's going to be 100 plus 70 plus angle G, which is also 100, plus angle H, not sure, well, angle H, and they should add up to 360. And when you do all the work, 170 plus 100 is 270 plus angle H equals to 360. And then subtract 270, subtract 270. That means angle H is going to be 90 degrees. There you go. That is it for this lecture. I think the next video should be uh, similar polygons. Okay, we're going to stop here.